Here is the next example. In this example, we're finding stability of the system by using Routh Hurwitz criterion or Routh Hurwitz method. Okay, so here is a characteristic polynomial s to the power of 5 plus s to the power of 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. So first we'll write down the s to the power of 5 term. So start writing, that's the first term. Start writing coefficients of each alternative term. Okay, so I wrote the s to the power of 5, s cube, so this goes here, s cube goes there, 3s. Okay, now second row starts with s to the power of 4, that coefficient of s to the power of 4 goes here, the next one goes there, next one goes there. Okay, now we're going to find unknown terms s to the power of 3. Okay, how do you find the first term? This first term is we're going to multiply these two first. So 2 times 1 minus multiply these two, 2 times 1 divided by this term goes right there. Okay, so that value is 0 here. This value becomes 0. So when you put 0, it's going to affect our calculations. What I'm going to do, according to Routh Hurwitz criteria, they said that take this as a very small positive number. So I'm going to take that as a 0 plus. 0 plus is a very small positive number, like 0.000001, something like that. Okay, now the next term is I'm going to take these two and take these two. So it's 5 times 1 minus, my apology, I always write that, it's always 1 times 3 minus 5 times 1 divided by 1. Okay, and this term is not there, so 3 minus 5 over 1, which is minus 2. Here we'll end up with minus 2. Now the next term is s square. Here we're going to take, let me use different color, we're going to use these two. And these two. Okay, these 4 elements, we're going to take them as in the matrix format basically. Now multiply these two together. Remember, that's a very small positive number. 2 times 0 plus minus of minus 2 times 1 over 0 plus. Okay, now I will talk about it in a minute. Actually, let me talk about it. So this is 2 times 0, which is 2 times 0.00, it's a very small number. This is very small number, minus of minus plus 2, right? So this will be very small number plus 2, so we'll end up with 2 plus 0.000002, something like that. So 2, I can take that as a for time being 2 divided by 0 plus, which is very, very small number. So something over small number, what happens? That will become very big number. So what I'm going to take, that big number, I'm going to take that as infinite. Okay, now we'll find this. So here we're going to take these two terms. I don't have anything, so these two terms, that will be, okay, so 0 plus times 5 minus 1 times 0 divided by 0 plus. So what happens? This value is 0. 0 plus get cancelled out. We'll end up with only 5 there. Okay, now s to the power of 1. Now when it comes to the s to the power of 1, we're going to take all these terms. Let me put this as 5 here, positive 5. Okay, now s to the power of 1 equal to these two multiplied, so infinite times minus 2 minus 5 times 0 plus divided by infinite. Okay, so 5 times 0 plus, very small number. I can consider that as 0. So if I consider this as 0, what happens? Infinite get cancelled. S equal to, okay, get cancelled, we'll end up with minus 2. Remember, infinite is basically, it's a very large undefined number, right? But in this example, it's a defined number. I'm taking that as infinite as a defined number, very large number, very large defined number. Okay, so that's the reason I'm able to cancel infinite over infinite. Okay, so we'll end up with, there it's minus 2, so this value becomes minus 2. Okay, how about here? This value is going to be 0. Now we'll do it as one more time here. So we'll use these 4. Okay, so infinite is very large defined number, and 0 plus is very small defined number. Okay, so it could be like 0.000000001, something like that. Okay, and infinite is 1 over that number is going to be infinite basically. Now I'm going to multiply these two and minus multiply those two. So very large number multiplied by 0 is going to be 0. So 5 times minus 2 divided by 5 times minus 2 divided by minus 2, these two get cancelled out, we'll end up with 5 here. So the element here is 5. Okay, now we look into the first column. Okay, so don't take this as an undefined infinite. It is defined very large number, very big number. Okay, so positive 0 plus, that's also positive number. As I mentioned, 0 plus is above 0, so that's a positive number. Now there is a sign change one time, again sign change another time. So anyway, one time sign change is good enough, knowing that this system is unstable. Okay, now so this system has 2 unstable poles. Okay, so this system has 2 unstable poles, so this system is not stable. Thank you.